So it is gonna be 1 point something, I think, because 10 square over 96.43.
1.04.
1.04. And unit?
Watts.
1.054 watts. What is this? 5. How you are getting minus 0.104? First of all, what is the unit of RT? If it is not clear, definitely here you will be having wrong. So no one write the unit of RT. You are just writing numbers. So number is not communicating exact thing. Always write the unit. 96.43. This is in ohm. And then you are calculating. Okay. So this is the way, or you can individually calculate. All right. Now, see next question. So assume there are 8 resistive wires that form rear window defroster for an automobile. Okay, do you know rear window defroster? Anyone knows about it? No. No one knows this one. Okay. Okay. Have you seen to the rear window, of your car? Like if this is your car, so the rear window. Here, rear window. So okay, I'll make a car for you. Like this is a car. Okay. So yes. So something, so there you will observe some lines. Some lines are there, red color lines, very fine lines. Noticed? Anyone noticed this one?
Yes.
If not, now you can. Yeah, checked. Huh? So this is there. And what are these? Basically, these are resistive wires, and the role of it that, during the foggy wind, weather. So if it's the fog deposit or, just cover the window at that time. So we turn on these, and what happened, because these are the resistance, and we know that how the power, consumed in the resistor, it is in the form of heat. So when it is turned on, the wires become heated, and it's clean your window glass at that time. So this is what we call rear window defroster. So now picture is clear to you. So they are saying assume 8 resistive wires that forms a rear window defroster. Okay, for an automobile. If the and you can see how they are connected. You can see they are just lines over there. So it is something like that. 1, then you can say 2, 1 more 3, and so on. So how many we have? This one. And by the way, they are connected in parallel. So this is R1, R2 up to R8, and then we have power supply connected, and they are saying how much it is connected. 12.6 volt is connected. Okay, and now if the defroster dissipates 90 watt, so defroster is dissipating 90 watt. So which power is this? Is this the total power or the individual power? What is that one?
The total power.
Total power. So this is the total power. So you have given PT is equal to 90 watts. You have given VS, which is equal to 12.6 watts. And you have given anything else? 8 resistive wires. Yani N is equal to 8 is given to you. So this is something what is given to you. Now you need to solve. You need to find 2 answers. First, what power is dissipated by each resistive wire? Now, calculate. Tell me.
Uh, 11.25 watts.
11.25 watts. Okay. So may I know the formula? Which you
I
people are.
divided 90 watts by 8.
No, what is the formula? And why did you divide? I don't ask you divide or multiply. There must be some logic. There must be some formula behind it. Which formula is this?
I I thought that each of the 8 wires will dissipate 1/8 of the total power.
Of the total power. Okay, but there is a formula. I have already taught you that one. You know what? Because what they said here, we know that formula. What is that? PT is equal to P1 plus P2 plus 3. We know that this one, you know, and all powers will be same. Actually, we know this formula, right? So from this formula, so because all resistance are of same value, by the way, here, you know, one because this they are forming a mesh here, something. So it is like we can say 8P. Understand? Then we can say the power of individual power or PR, any resistive power. So it is gonna be PT over 8, and yes, this is something. Here is gonna be how much? 90 over 8, and which is 11.1 watt. This is the formula. Is this one actually? You know, the logic. You divide. You are also right, but I was asking the formula. But what you did there is absolutely right, because your logic is that because it is divided into 8, so I just divide by 8. All right. So next one, what is the total resistance of the defroster? Second part, what is the total resistance of the defroster? 1.76 ohm. Okay. How did you calculate total resistance? Which formula?
We can say the voltage to the power 2 over the power.
Okay, which power?
That we found.
Okay, total or individual?
Total. The total.
Total power. Okay, so you are saying R is equal to
V to the power 2.
Yes, so Lina said V square, yani Vs square, source square over PT. Yes, total power. Yeah. So here you can get it. So V is already given to you, which is 12.6 square over total power is 90. All right. So answer is 1 point how much?
76 ohm.
Okay. All right. Good. So this is the way. So once picture is clear, then you can easily solve. So sometime you have seen that it is not, any questions are not going to come just, you know, circuit is given and you need to find current and power. But sometimes scenario is given, you need to understand what this you know, explaining here, and then you need to solve it. All right, so we have done with this. And what is the resistance of each wire? This is, you calculate the total resistance. Similarly, we can also get the total resistance. So which formula we need to use in order to calculate the individual resistance? As I told you, all resistance are of same value. Do you remember this formula?
Yes.
RT is equal to R over N. Remember this formula? Yes.
Yes.
So first, yeah, so here we can say R is equal to nRT, yani 8 multiplied by 1.76, which is 14.1 ohm. Correct? This is the way. So everything is based on the formulas or what we learn. So, and even, you know, in the next chapter, we are going to use any formula anywhere frequently. So all the formulas must be clear to you. That's why we put the, you know, we just decided to have these two chapters in the quiz rather than, you know, first and second and third chapter, because first chapter is just a very basic power or Ohm's law and all, you know, already all these things. So at least your, you know, two major or what you call basics chapters will be ready for the quiz, so that inshallah next chapter will be easily understandable. All right. So this is just summary. You can read it now. Let's see the quiz. Oh, none of them. The total resistance of a parallel resistor is equal to, okay, the sum of resistances, the sum of the B, the sum of the reciprocals of the resistances. Okay, B, one more B. Okay, only one D. Okay. So 4 students knows the answer. Every rest is sleeping.
What?
All are sleeping. Only I can
No,
see
we said B.
four replied here in the chat. I am just looking in the chat. So 4 students said B, 1 student said D. What have I saying?
I'm saying B.
B. Okay.
Me too.
D. Mariam is saying D. Shahad is saying D. Okay, BD. BD. Bereni Dharam. No one is saying A and C. Okay. Bereni Dinar, not Dharam. Okay. Okay, those are saying B. Is B correct?
No.
Or not correct? Why not correct?
Because it's the reciprocal of the sum of the reciprocals.
Absolutely right. It should be written here reciprocals of the sum of the reciprocals. Reciprocal yani 1 over, that is called reciprocal. Then the sum of reciprocals. So they are saying the sum of the reciprocal. Yani they are trying to say what is there. Yani this is something 1 over. Yani they are saying 1 over R1 plus 1 over R2 plus 1 over R3. But this is not correct. It should be reciprocal of the sum of reciprocal. Okay, so B is not correct, B is wrong, D is correct because none of the above. We don't have the exact accurate option given here. All right, next. Tricky. Okay. Yeah, circuit is not there. Okay. What is the answer? There is no circuit. Yeah, it was answer. So D. Any number. Okay. Mariam, what is your answer?
D.
D. It is again tricky. All are saying D, mashallah. D's depend on the, okay. The number of nodes in a parallel circuit is A. Zahra, only one? Any one node? Okay. What should I say now? Should I say correct or should I say wrong? What is your guess? Ashwak? D 100%. Oh, no, someone changed. Jana changed to C3. D. No, C. Okay, all are wrong. Mariam is correct. B. 100% wrong. 100% wrong. B. If we are saying that number of nodes in a parallel circuit. So parallel circuit. So parallel yani purely parallel talking about. It's not a yani what you call combination or something. So when it is parallel, so you are going to have 2 nodes only. Okay, do you want to see some circuit we have learned here?
Yes.
Okay, now tell me how many are there? Is this 2 nodes or not? Yes. Okay, see another example. These 2 examples both are parallel, 2 nodes. All right, go back. See this one. How many nodes? If you forget, just for your knowledge, I told you this is a single point, 1 node. This is a single node, 2 nodes. So when we say purely any parallel, so it is gonna be See this one. How many nodes?
2.
So from here to here, 2 also. You just while here, and this is again a 2 nodes, left and right. You can see. So 2 nodes. So when we say parallel, it's basically see here. One more example of parallel. 2, 2. This is not example. Okay. Now, can you tell me, is this parallel circuit or series circuit or combination circuit? I am here, Lina. I think you are talking about this. Yes. Don't convince. Okay, no problem. Just wait. Okay. Fai, give me the answer of this slide. Is this a series circuit, parallel circuit, or combination circuit? Then you will convince.
Combination, right?
Combination. Okay. Okay. Just wait for others' answer. Then I will tell. Okay, Shahad. All right. Combination. Let's see others. What do you think? Is a series, parallel, or combinational? Mariam said parallel. Combination. Okay. Combi. Okay. Parallel. So combi parallel. No one is saying series. All right. So it is a combinational circuit. Roba, yeah, it is a combination circuit. Now you can say why it is combinational, why not parallel, doctor? And now you said here is a 3 nodes. So by the way, it is 3 nodes. Yeah, it is true. What are the 3 nodes? You know, from here to here, I said same point. From here to here, I just a minute. Let's draw again. From here to here, this is a single node, and I also said this is a different node. Why it is happening here? See now. So this one and this one, these two actually connected in series, you know, this branch and this branch. So how current will go? The current will go this way and current will go this way. Yani both will share the same current. Once current reach here, now it is gonna be divided into 3 parts. Also keep in mind, you know, and because of the combination circuit, you will clear, you know, things will be clear in the next chapter. So this is in series. These two components are in series. They are in parallel. Why? Because they are sharing a common node. Let's give the example name A and B. Yani R3, R2, and this V0, yani current source IS. They are in parallel because they are connected between A and B. They are parallel. All right. Now VS and R1 is not a parallel, is not in parallel. Even VS is not parallel to anyone because it is basically in series with R1 first, then this combination. Yani if I say from here and to here, this is in combination with R2, R3, and this one. But alone, neither R1 is in common, you know, in parallel, nor VS is, you know, parallel here. So they are in series first, then their combination, yani their, you know, addition, whatever you call it, is you know, in parallel with that one. So the thing is, this is a series connection, this is a parallel connection. So this is a combinational circuit, combination circuit. Is it clear now?
Yes.
All right, you will learn about the combination in the next chapter also. Yeah. Any question?
No.
All right. So 5 clear now? Convince? All right. Yes. So inshallah, after this chapter, we start next and combination, and that's why I told you this has to be clear. What is series? What is in parallel? And I explained to you when the current will start flowing from here to here. So same current will go here. Okay. Yani then after that current will split because they are in parallel. So current will split. So up to here, same path, current path. So these two components are in series. By the way, we cannot add them because this is a voltage source, this is a resistance. So they will be like as it is. But if you want to simplify this one, So we will learn simplification in the next chapter. Just leave it for now. Okay. So we were discussing this one also tricky. No one will do me. By the way, I will restart the quiz. More tricky questions will come. See this one. A 2.52. Okay. Okay. How many ways do you think we can apply here to solve this circuit, or ways or formulas, whatever? Think in your mind. Is there any way, one way to calculate the total resistance, or could be any other or more than one ways? How did you solve it? Which formula you apply? Okay. This formula, okay. All right. So do you think, do we have any other formula? More than one. Okay. So, okay. So you use this formula. Okay. And also, do you remember that formula I told you? Three resistors are in parallel. So I can also use R1, R2, R3 over R1, R2 plus R2, R3 plus R1, R3. Okay. This could be, okay. You can also use it. So how many ways of, and any two formulas, this one or that one, this is possible. Also, one more is possible, you know. Which one? Do you remember product over sum rule?
The same first.
Sorry, again?
We can add the same first together and then add the third one.
Okay, yeah, this is also, yeah. Yes, Zahra, yeah, you are right. It is possible, which is I am going to tell you. See, because these two resistors are of same value, correct? So do you remember the rule when two resistors are of same value? What will be their parallel combination?
Yes, it will be
10 by 2. Yeah, Mariam, correct. Half. Yeah, by divide by n. Fine. Yeah, you all are right. So just what I can do in place of these two resistances, you know, I can make a single resistance. That is what I can give the name. Let's suppose R4. And what is that? How can I get it? Its value is gonna be 5k. Sorry, yeah, 5k because of the rule half. And now this is remaining as it is. This is R3. Clear? Now, two resistors are in parallel. Do you remember a formula when two resistors are in parallel? Shortcut. Product over sum rule.
R4 multiplied by R3.
Yeah.
Divided by R4 plus R4.
Yes. Yeah, correct. Any product over sum rule. So I can also solve this way. Okay. So this is, it is going to be 5 multiplied by 5.1 over 5 plus 5.1. You got it. You will be getting same answer exactly. Okay. So three ways are possible. That way, whatever you like. I want to teach you, always different ways, whatever it is like in my mind, so that you feel free whenever you feel, okay, this is easier one, or we can easily solve that is more easy. Sometime, we just give three of same value like that. So some students did not get that point in mind when similar value distance are in combination. So the total is gonna be simple R over 3. So they will be using other two formulas, wasting time. So you need to think about. That's why practice is important. Okay. All right. So the answer is A. Okay, it's so simple. I just explained this one. Yeah, so 1/3 the value of one resistor. Correct. A.
B.
Okay, yeah, equal to the, and which rule is this?
Kirchhoff's current rule.
Yes, Kirchhoff current law, KCL. Yeah, in short, KCL is okay. Yeah, KCL or KBL. KCL is applicable for parallel circuits where nodes are, we can apply anywhere where we have nodes. All right. Current divider formula. Yeah, see, yes, I told you how to memorize it, and I spent some time for this. I told you this is 1, it will be 2. That is something. It is 1, it is 1, cannot be. Okay, this ratio is, this is something for the voltage divider. And what voltage divider is? V1 is equal to I1 over R1 plus R2 multiply by Vs. This is the voltage divider. Okay, B and C difference. In B and C difference, okay, Lena said, what is the difference between these two? Yes. Okay, is there anyone who can tell the difference? Good question. Yeah, good question, Lena. Yeah. So
Maybe because there might be more than 2 resistors.
It's because RT and parallel is not R1 plus R2.
absolutely right, Shahad. Very good. Yeah. Yes, 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 yes.
It's equal to 1 over.
Correct. Yeah, Handi. Yeah. See, so difference. Yeah, very good. At least you reply. See, whenever we say RT for parallel, you know, it should be basically should be like that. Yani 1 over R1 plus 1 over R2's inverse. Correct. This is the RT for the parallel, but this is not the RT. This is just a sum R1 plus R2. Understand? So we cannot rewrite here RT because it leads to confusion. Whenever we say RT, it means it is like that, and we have this one shortcut formula. So hope it is clear to you now. That's why we are not writing RT. RT for parallel, it is something like that. Okay. All right. Good. Okay. Next is. Okay, so majority says B, 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 except one student maybe by mistake or blowing, I don't know. All right, so D is there. Majority is saying D. Okay. Okay, so how did you calculate it?
By finding the total.
Can you hear me?
Yeah, I can hear.
Okay. First, we do RT. We must find RT. So 10 multiple 2 key over 10 key plus 2 key.
Yes,
Okay?
correct.
This is our total. Okay. We find it over. After that, we put I. Okay, current. we should find the current. So we put V over RT. Okay.
Yes. Yes.
V is 12 over 1.67 key. So we have 7.2 milliamps.
Very good. Good. So hope everyone use this step as the student just mentioned. Also, now, do you try any other way? Anyone try any other way except finding total resistance and then dividing by that one? Okay, Haifa, you are saying 2 steps. What is another one? The one you already explained. Calculate the total and then divide by the VS divided by total and get the total current, which is 7.2. Absolutely right. Any other way, girls?
For me, I didn't use 2 steps. I put everything in one formula and find the current.
Okay, Yani, you use the same steps which was your previous student just mentioned.
Yeah, but only one formula, not 2 steps. Only one step.
All right. So yeah, Haifa, yes, this is Yani. Can we calculate individual currents like I1 is equal to V1 over R1? Okay. Another one, I2 is equal to V2 over R2. Okay. By getting this, then later on I can apply KCL, Kirchhoff current law. Then I can also calculate this way. Is it clear? Okay. Yeah. Good. So yeah, Yani, just need to, we have to think broad way rather than just only one way. Yeah, this is also possible. Whatever you like, you go for it. You are not restricted to that, but you should know how can we go for it. All right. Okay, so go for next one. Answer is D, which is 7.2. All right. Calculated. Okay, so what majority is saying? B. Okay, then 13.3. 13.3. I1 R2 over R1 multiplied by IT. Okay, which formula is this? Is this new formula? Mariam, check your formula.
It is R2 over R2 plus R1 multiplied by I total.
Yeah, so Yani, you should write R2 over R1 plus R2, Mariam. Okay? Yeah. Okay. So this is R1. Yeah. No problem. No problem. So we learn from our mistakes, So I believe we should do mistakes. All right. So what is this, Fatima? In this case, you can know it without calculating. In this case, which case you are saying, Fatima? B. Any case maybe you are thinking? Yeah, okay. Okay, so everyone, I think, apply current divider formula here. Am I right?
Yes.
Okay, so yes, this is the easiest one. Okay, see, yeah, we know that, but yeah, if you want to know without what you called calculation, without formula, okay, so just let me think, how can we say? Okay, this is something what I can, but getting exact value is not possible, but some logic is possible. See, this is 100 ohm. So whatever this is gonna be have, let's suppose their current is X. Okay, this is 200 ohm. So yani double of it. So how much it is gonna be having current? Do you know? 2x. Yani double current. More resistance double or opposite. X by 2.
No. Half current.
Half current, yeah, okay, which is X by 2, which is possible. But see, I don't know what is X. So what I can say one thing. What? X plus X by 2 is equal to 200. This is simple mathematics, by the way. This is simple mathematics, right? So mathematics we can apply anywhere. It is not a formula, but we know that why I just add them, because KCL, total current, is equal to X plus X by 2. So now I can say 2X plus X is equal to 400, and now 3X is equal to 400 by after multiplying 2 there. So it is something like that. Now I can say 400 divided by 3. Just check it and know what we are going to have. Is this 40? Because, yeah, correct. Yeah, 40 by 3. Now check what is 40 by 3 is coming.
13.2.
Same. Correct. So some basics we can also apply. Interesting, but see, this is not the actual formulas which we learn. This is just simple mathematics because of the ratio. This is the problem of ratio. One is 100, another one is 200, because it's a twice, and we know the logic that more resistance will be having less current. So, and their ratio is a double, so the current is gonna be half. So I can also say, yeah, it will work whenever we have a ratio, definitely, if the ratio is clear. But if it is like that, R1 I give you 25 and R2 I give you, something like 97. So this time you cannot say X by 2 or X by 2, So their ratio has to be clear. Understand? It will not always work. It is only in case when ratio is double, half, quadruple, something. We can just apply simple mathematics. But see, I would not ask you, to do this one. Don't do this one, because it is something, though you will be getting the answer. This is okay as long as you are, solving multiple choice questions. Once you are solving, theory question, no, it is not, recommended. It's better you just write the simple formula, that is current divided the rule, or that way. Okay, I just explained this one because someone asked me teacher without any calculation, so that's why I just solve it. Okay, because it's mathematics, so and we can apply anywhere if the ratio is clear. All right, but it is recommended you will do that one. As long as you are just solving any multiple choice question, I'm not going to check your solution at all. I will just check whether you choose B or A. So that is absolutely right. But if any question for the solution, so you should write authentic formulas, KCL, KVL, Ohm's law, whatever. Okay. Okay, move to next. C, all right. 1.33. Okay. Okay. So they are asking this time voltage actually. So 1.33 is the answer. Okay. Same, we can apply the same way the previous question, the concept. So we know the X value and what we get it. So we know that one, the current, then we can multiply with the resistance, then we can get this one. All right. Okay, quick question. Let's see who will respond first. Quick question. I am going to ask. I am just looking for the response in the chat. Okay, the question is, how much is the voltage across R2? Okay. Correct. Yeah, it's gonna be same. Correct. Yeah, 1.3. They are in parallel. That's why. Good. All right. Good. As long as you are enjoying, I am enjoying my course. You know, feel free. We should not have pressure like, oh, electronics. So yeah, it's good. All right. So the total power dissipated in a parallel circuit is equal to D, average of sum of the parts in all the resistors. Correct. This is even one more thing I would like to add. It is not only parallel, it is also applicable for series. Correct? This is also, yeah. So this is something more which you can add here, which is also applicable for series. All right. So this way we have, I believe, done. There are some reference questions which you go through, 6, 7, 8, 9, 10, 11, 12, something like that. You can go through and just try to practice as much as you can. Yani, I want something from you before the test. Yani, these up to 4 chapters, chapter 3 and 4, yani, 3 and 5, sorry. Oh, sorry, 4 and 5, which is series and parallel, has to be clear. Yani, you don't need to study again and again same thing for the midterm examination. For the midterm examination, next chapter you can focus and it should be ready, inshallah. And this way you will be scoring good marks in your quiz, and then you will be ready for the final midterm exam also. Questions is not decided, Lina. It is according to the time given, inshallah. Even, you know, question doesn't reflect you know, the time. Actually, sometime I can give you so tricky question even you cannot solve within 15 minutes, and sometime I can give you 5 questions or 10 questions which you can just solve within 15 minutes. So inshallah we'll design in a way you know, you will be having sufficient time to solve it. But again, it is not like that you are sleeping and thinking a large formula. So okay, can you hear me, girls? There is a disconnection and now it's connected.
Yes.
Yeah, okay. So yeah, number of questions is not decided yet, and don't worry about the number of questions. It will be, you can easily solve it. It will be like that. You can solve within that time limit. All right, so this way we have done with chapter, girls. See, if I be kind, you will be not kind. Everyone will be getting A plus, A plus, A plus. So I am looking to find the true A plus. The true A plus. Okay. So let's see who is the